For much of the late 20th century, Caterpillar did not simply participate in the American trucking industry. It ruled it. Yellow engines with black lettering became a rolling symbol of authority on the highway, a sign that a truck was built to work hard, pull heavy, and survive punishment that would destroy lesser machines. At the center of that reputation stood one engine above all others, the Cat 3406. For nearly 2 decades, it defined what heavy-duty highway power was supposed to be. It hauled the heaviest freight, ran the longest miles, and earned fierce loyalty from drivers and fleets who believed nothing else could match its strength. But the same philosophy that made the 3406 legendary would eventually help drive Caterpillar out of the on-highway truck engine market altogether. When the 3406 emerged in the mid-1970s, the trucking world was undergoing a fundamental shift. The era of high-revving 2-stroke Detroit diesels was beginning to fade, and fleets were demanding engines that could deliver torque without living at the top of the tachometer. Fuel costs were rising, freight loads were growing heavier, and interstate trucking demanded engines that could hold steady speed hour after hour without complaint. Caterpillar, already a dominant force in construction and mining equipment, saw an opportunity to bring its industrial philosophy to the road. Their belief was simple. A truck engine should behave like a bulldozer engine. It should be slow, strong, and nearly impossible to kill. The 3406 was built entirely around that idea. It was a massive inline 6-cylinder engine displacing 893 cubic inches, designed with thick castings, enormous bearing surfaces, and a bottom end that looked excessive by highway standards. Where competitors chased higher RPM and lighter rotating assemblies, Caterpillar focused on torque and mechanical reserve. The engine made its power low in the rev range, exactly where long-haul trucks spent their lives. Drivers quickly learned that a 3406 did not need to be rushed. It pulled steadily and confidently, even when gross weights climbed far beyond what regulations imagined. One of the defining characteristics of the early 3406 was its mechanical simplicity. Fuel delivery relied on Caterpillar's mechanical unit injectors, driven directly by the camshaft and controlled through straightforward rack settings rather than electronics. There were no sensors to fail, no control modules to confuse mechanics, and no hidden logic governing fuel flow. If the engine ran poorly, the problem could be found with tools, experience, and patience. For fleets operating far from dealers or for owner-operators who did their own maintenance, this simplicity was priceless. The 3406 also benefited from Caterpillar's industrial DNA. The crankshaft was massive, forged to handle continuous, heavy loads without flex. Connecting rods were overbuilt by highway standards, and piston cooling jets kept temperatures under control during long pulls. Cooling systems were designed with margin rather than precision. The engine did not live on the edge of thermal limits. It lived comfortably below them. This design philosophy meant the engine was heavy, but weight was a trade many fleets were happy to make in exchange for reliability. By the late 1970s and early 1980s, the 3406 had become a dominant force on American highways. It found homes in Peterbilt, Kenworth, Freightliner, and international trucks, particularly in applications where weight and durability mattered more than fuel economy. Heavy haul operators embraced it. Tanker fleets trusted it. Owner-operators who ran coast to coast swore by it. Stories spread of 3406 engines running 1 million miles before requiring major internal work, sometimes more. Whether every story was true hardly mattered. The belief itself became part of the engine's legend. Caterpillar continued refining the platform through the 3406A and 3406B variants, improving airflow, strengthening components, and raising horsepower ratings while maintaining the same conservative core design. Horsepower numbers climbed steadily, yet the engines remained calm and unstrained in operation. Drivers noticed that where other engines screamed under load, the Cat simply leaned into the pull. It was not exciting in a dramatic sense, but it inspired confidence. That confidence became loyalty, and loyalty became market share. By the late 1980s, Caterpillar had achieved something rare in trucking. They were not just an engine supplier. They were a status symbol. Trucks equipped with Cat power commanded higher resale values. Fleets advertised Cat engines as a selling point. Drivers requested them specifically. Caterpillar's yellow badge had crossed from construction sites onto the highway and carried the same meaning in both places: toughness, longevity, authority. But beneath that success, subtle warning signs were beginning to appear. The 3406 was engineered with the assumption that mechanical simplicity and physical strength would always outweigh efficiency and emissions concerns. That assumption had held true for decades, but the industry around it was changing. Fuel prices fluctuated wildly. Environmental regulations tightened year after year. Government agencies began looking closely at nitrogen oxides and particulate matter in diesel exhaust. Where Caterpillar had once competed primarily on durability, they now faced a future where compliance and efficiency would determine survival. The early 3406 engines were thirsty by modern standards. They burned fuel generously in exchange for torque and longevity. For owner-operators, this was often acceptable. For large fleets watching margins shrink, fuel consumption became impossible to ignore. Competitors like Cummins and Detroit Diesel began investing heavily in fuel efficiency, electronic controls, and combustion optimization. Caterpillar remained confident that their mechanical approach could be adapted as needed. After all, no one questioned their engineering capability. The question was whether their philosophy could evolve quickly enough. The 1990s marked the beginning of a new era for diesel engines. Electronic fuel management was no longer experimental. It was becoming standard. Emissions standards tightened again, forcing manufacturers to reduce exhaust output without sacrificing performance. Caterpillar responded with the 3406C and later the 6Z and 6NZ engines, incorporating electronic controls while trying to preserve the rugged personality that defined the brand. These engines remained powerful and respected, but complexity crept in. The simplicity that mechanics loved began to erode, replaced by wiring harnesses, sensors, and electronic control modules that required specialized diagnostic tools. At the same time, Caterpillar's core strength in off-highway equipment began to work against them. Their engineering culture prioritized absolute durability under constant heavy load, not the fuel efficiency and emissions flexibility demanded by long-haul trucking. Where Cummins and Detroit increasingly designed engines specifically for highway duty cycles, Caterpillar adapted industrial designs for road use. The difference was subtle at first, but it grew more significant with every regulatory change. By the late 1990s, Caterpillar faced a crossroads. The 3406 lineage had carried them to the top of the highway market. But the road ahead demanded a different approach. Emissions regulations scheduled for the early 2000s would require dramatic reductions in exhaust output, and meeting them would mean embracing technologies Caterpillar had long avoided. Exhaust gas recirculation, advanced electronic controls, and later after-treatment systems were becoming unavoidable. For a company built on mechanical certainty, this represented a fundamental challenge. Still, confidence remained high within Caterpillar. They believed they could adapt without compromising their identity. The engine that had conquered the highway for 2 decades would evolve once again. But the changes coming would test the limits of that belief, and the decisions made in the years ahead would ultimately determine whether Caterpillar could remain a highway power leader or whether the road would finally end for Cat truck engines. And that moment of reckoning was closer than anyone inside the company wanted to admit. As the new millennium approached, the diesel engine industry stood on the edge of its most dramatic transformation since the end of the steam era. Emissions regulations scheduled for the early 2000s were no longer abstract future threats. They were firm deadlines backed by law, and every manufacturer knew that failure to comply would mean exclusion from the on-highway market. For Caterpillar, this moment represented more than a regulatory hurdle. It challenged the very philosophy that had made the 3406 legendary in the first place. The emissions standards introduced in the early 2000s demanded sharp reductions in nitrogen oxides and particulate matter. Achieving those reductions required precise control over combustion events that purely mechanical systems could no longer deliver. While competitors like Cummins and Detroit Diesel had spent years refining electronic fuel management and preparing for exhaust aftertreatment, Caterpillar pursued a different path. They believed that advanced in-cylinder combustion control could meet emissions requirements without relying on exhaust gas recirculation or particulate filters. This belief gave birth to what Caterpillar called ACERT technology, short for Advanced Combustion Emissions Reduction Technology. ACERT was ambitious. It relied on multiple, precisely timed fuel injection events, high-pressure electronic unit injectors, and carefully shaped combustion chambers to burn fuel more completely inside the cylinder. The theory was elegant. By controlling combustion itself, emissions could be reduced without adding complex exhaust systems that Caterpillar feared would compromise reliability. In practice, however, the approach proved far more difficult than anticipated. The engines that emerged under the ACERT banner were powerful and, in many cases, durable. But they were also complex and unforgiving. Multiple injection events increased heat and stress inside the cylinder. Cooling systems were pushed harder than ever. Electronic systems multiplied, introducing failure points unfamiliar to technicians who had grown up on mechanical Cat engines. Fuel quality became critical. Sensors had to communicate perfectly. When everything worked, the engines performed well. When something went wrong, diagnosing and repairing the issue often required specialized tools and training that many fleets did not yet possess. At the same time, fuel economy suffered. In order to meet emissions targets without exhaust gas recirculation, ACERT engines often consumed more fuel than competing designs. Fleets began to notice the difference immediately. Long-haul operators, already operating on thin margins, could not afford engines that burned more diesel simply to satisfy emissions rules. The very customers who had once embraced Caterpillar for its strength and simplicity now questioned whether that strength came at too high a cost. Driver perception also shifted. The calm, confident pull that defined the 3406 was still present, but it was accompanied by more frequent regenerations, higher operating temperatures, and electronic behavior that felt foreign to those accustomed to purely mechanical engines. The emotional bond between driver and machine began to weaken. The Cat engine no longer felt like a straightforward tool. It felt like a system that demanded understanding rather than instinct. By the mid-2000s, the on-highway diesel market had become brutally competitive. Cummins had refined its emissions strategy and delivered engines that balanced compliance, fuel efficiency, and reliability. Detroit Diesel, under new corporate ownership, embraced advanced electronics and integrated engine and chassis systems. Both manufacturers invested heavily in dealer training and diagnostics. Caterpillar, meanwhile, remained committed to its combustion-first philosophy, even as customer feedback grew increasingly critical. The final blow came with the emissions standards scheduled for the late 2000s. Meeting these requirements would require either full exhaust gas recirculation systems, diesel particulate filters, or selective catalytic reduction technology. Each option conflicted with Caterpillar's long-held beliefs about simplicity and durability. Adopting them would mean redesigning engines from the ground up, investing billions in new technology, and accepting a level of complexity the company had spent decades avoiding. Faced with that reality, Caterpillar made a decision that stunned the trucking world. Rather than compromise its engineering identity or enter a technology race it no longer believed in, Caterpillar chose to exit the on-highway truck engine market entirely. The announcement marked the end of an era. The company that once defined heavy-duty highway power would no longer build engines for long-haul trucks. The decision was not made lightly. Caterpillar understood the loyalty they were walking away from. They knew the 3406 had become a legend. They knew fleets and drivers would remember their engines long after production ended. But Caterpillar was, at its core, an industrial company. Construction, mining, marine, and power generation remained its strongest domains. By leaving the highway, they could focus resources where their philosophy still aligned with market demands. The aftermath was immediate. Fleets that had standardized on Cat power shifted to Cummins or Detroit. Dealers adjusted. Truck builders reconfigured their offerings. The yellow engines slowly disappeared from highways where they had once ruled. Yet the legacy of the 3406 refused to fade. Thousands of engines continued running in older trucks, working vocational roles, hauling heavy loads, and proving that the core design remained sound even as the industry moved on. Today, the 3406 occupies a unique place in diesel history. It represents the peak of mechanical heavy-duty highway engineering, an engine built with margin, confidence, and an almost stubborn refusal to compromise. Its rise was earned through real-world performance and durability. Its fall was not the result of failure, but of misalignment with a rapidly changing, irregulatory environment. Caterpillar did not lose the highway because it forgot how to build engines. It lost the highway because the rules changed, and the qualities that once guaranteed dominance became obstacles to adaptation. The story of the 3406 is not a cautionary tale about engineering incompetence. It is a lesson in how even the strongest machines can be left behind when the world demands something different. And yet, for those who know, the sound and feel of a cat pulling under load still defines an era. The engine may no longer be built, but its influence remains etched into the culture of trucking itself. The 3406 did not fade quietly. It earned its place, carried the industry for decades, and exited on its own terms. Few engines can claim that legacy.